This here is an escape room puzzle, meaning that you have to solve all its pieces in order to finish the escape room. As you remember, some time back I've made a video on my own escape room that was based on an Arduino and a submarine story. And that was a lot of work. And since then I had a lot of requests for making escape room puzzles. Basically, an escape room is a game where you have 60 minutes usually to solve all the puzzles in that room and get out of that room. Well, in this case we don't have that room, because all the puzzles are inside of this 3D printed case. This is an easy puzzle, but I would like to start a new video series where I will make escape room puzzles, each time getting harder and harder. I even seen some puzzles on the internet that could cost you $20,000. And since my brother wants to turn on his PC in a more geeky way, the purpose of this puzzle is to turn on a PC, but you could use it with any other idea. Let me show you. The player would need to find a USB drive key, this other normal key, to find a code of 4 digits to place on the touchscreen, and then use the fingerprint. Now the fingerprint part can't really be used in an escape room, because you would need a real fingerprint or to scan the finger of all the players before the game starts. But we have multiple ways to simulate a fingerprint in an escape room. In this case we turn on the box with this emergency button.
Master key required.
So you can hear the sound that the master key is required. We insert the USB drive key. After the message we must enter a 4-digit code, which could be for example a birthday date, such as 3007. So once this code is inserted, you must flip the 3 switches and rotate the key switch. And then you will be requested to scan your fingerprint.
Please scan your fingerprint.
If the fingerprint is okay, the final step is to push the button.
Welcome, Master. You can press the on button now.
Okay guys, so the final step when everything is complete with this escape room puzzle, all I have to do is to push this button and it will send a radio signal to the receiver, which in this case is connected to my PC, but you could connect it to anything else that you want, maybe a relay, a lamp, and so on. So let me just push this button and start my PC with a radio connection.
System initialized. Welcome back.
So there you have it. With just a push button, you can control anything, and in order to push it, to be able to push it, you have to solve the entire puzzle. So that's it guys, that's the example. Now let's see how to build this. So let's get started. Video sponsored by PCBWay. If you have a PCB project, you must check their services. For example, try the PCB prototype service, for boards from 1 layer up to 14 layers. The PCB quality is amazing. Nice finish, good silk layer and exact sizes. And the production time is measured in hours. So all you have to do is to upload the Gerber files of your PCB, select the settings such as the color of the board, the size, the thickness and so on, and order the PCBs for only $5 for 10 PCBs of 10 by 10 centimeters. In just a few days you receive the PCBs, so you could finish your amazing project in time and with a professional look PCB. What's up my friends, welcome back. So I think I'll start a new video series with escape room puzzles ideas. I guess I have enough experience with escape rooms and Arduinos, since for years I've made my own escape room. For this project I will use a 3D printed case, which I will make to look cooler with some carbon fiber vinyl. We also need a fingerprint sensor like this one, with UART communication. A big push button of any color. We need this type of key switch. A broken USB drive or USB adapter that is very cheap. An emergency switch like this one. The Nextion touchscreen display. A DF player in order to play some sounds. A micro SD card and a speaker. And for the RGB colors we could use some WS 1812 LED strip. And to control everything I will use an Arduino. And since I need a little bit more memory, I will use an Arduino Mega. You could connect the output to a wire, but in my case I would use some radios. So we also need 2 UNRF24 radio modules or some 433 MHz ones. Also you can use a buzzer if you want to add some beeps to the system. And to supply everything you could use a fixed supply, but in my case I want to make this portable, so I will use batteries, with a buck converter set to 5 volts. We also need 3 toggle switches, and for this I've also printed these covers with 3 different colors to make the case look better. Okay, so let's start. You have the connection schematic below this video. And since the final code is quite long, I will show each part separately, and you will have an example code below as well. One example for the fingerprint reader, another example for the Nextion display, one for the DF player, and so on. Okay, so we start preparing the 3D case. So go in the description of the video and download the 3D STL files. Print them without support with 3 parameters, 0.2mm layer height and 15% infill. Also print the covers for the toggle switches, and I've printed this part here with the ASUS ROG logo because I will give this to my brother to use it with his PC. So get the case and the carbon fiber vinyl. Measure it and cut it to size more or less. Then glue the vinyl and make sure it's well stretched. Then flip the case and cut the excess to size. Also cut the holes for the screen and the buttons. Now the case looks a lot better. We could now add the buttons. I first add the emergency switch on this corner. Next I do the same for the key switch. I make sure that the arrow is pointing upwards, so the key will rotate 90 degrees with the case. Next we add the toggle switches. For that we first connect the 3D printed covers with a metal wire. Then we add the switch followed by the cover. You could also add some glue. Then tie the knot and that's it. We have the toggle switches. Next I add the part for the USB drive that will be here on this transparent 3D printed part. For the USB connector I will take it out from this adapter. So I tear down this adapter and take the connector. Then I glue it here on the 3D printed part like this. So now we could insert the USB drive. After I solder 2 wires to the USB connector, I glue that part on the case like this. Now we need to add the fingerprint sensor. This will go here on this hole. We have to push it in and glue it like this. Now all is left is to glue the Nextion display here, but I will do that after I make some tests, and I'm sure that everything works. Next I want to add some RGB LEDs to the logo and behind the transparent 3D printed part. First I glue a piece of white paper behind the logo part, and that will diffuse the light. Next I make a small case out of cardboard and I will glue the LEDs here. I solder wires to the LEDs and glue them inside of the case, and make sure that they follow the data arrow on the strip. Now I can glue the logo on the main case and then add the cardboard box with the LEDs behind. After I glue the LEDs, I connect it to my Arduino and upload an example sketch, and I have to say it looks quite good. Okay, so then I glue another LED strip on the inside of the case so the light will shine through this transparent USB drive. I upload another test code and again it looks quite good, so now we can make some light effects as well. Before I add the rest of the electronics and make the connections for the buttons, let me show you how each part will work. First, the USB drive key. What I will do is to place a resistor inside of this USB adapter. Actually, I finally used a different one because the one that is made out of metal was hard to open. Then inside, connected to the Arduino, I have another resistor, as you can see here, connected to the analog input A0. So these 2 resistors will create a voltage divider, and the voltage will have a certain value. So all I have to do is to measure this voltage, and if it is in the desired range, then we have inserted the good USB key. I run a code and as you can see, I detect the USB key and turn the LEDs from red to green. Okay, so now I've connected the fingerprint sensor to the Arduino serial port. First upload the enroll example code from the tutorial in the description. Follow the instructions on the serial monitor in order to add a new fingerprint. So add the ID and then you scan your finger and it will be stored onto the memory. Now upload the second example code for the fingerprint read. As you can see, I placed the wrong finger and there is nothing detected. But now I place the finger that I've scanned before and I get the ID1, which is the one that I've used when I store the fingerprint. So that's how we use this sensor with the Adafruit fingerprint library. Read more below. As for the DF player, you also have a full tutorial below in the description. Basically we have some MP3 files on this SD card with names as 0000, 0001, 0002, and so on. And using the dfplayer library, we can send instructions to play each one of these files from the SD card. So make the connections, upload the MP3 files to the SD card, and upload the code to the Arduino. And as you can see, I'm now playing all the files from the SD card. It's that easy. Finally, for the Nextion display, you also have a full tutorial below, so please go and see that step by step. The difficult part is to create the TFT file for the display, but I've also shown you that in a previous video. You need another SD card, so first we copy the TFT file that you could download from below. Copy that to the SD card. Before you power up the display, insert the SD card. Then you power up the display and the TFT file will be copied to the memory. Now power down the display and remove the SD card. Now when you power it up again, you will have the TFT program running. This will communicate with the Arduino and receive and send information about the status and when the 4-digit code is inserted. I make the UART connections and give it a final test before I connect everything inside of the case. Okay, so I know that everything works. I make all the connections, and as you can see we have a lot of wires. So please check the final schematic below. Finally, I've placed a second Arduino Nano, and this will only control the RGB LEDs. Because having two RGB LED strips on top of the other code was too much for the Arduino Mega. I mean, yes, it could do it, but we would have a lot of delays. So now the LEDs are controlled by this Arduino Nano. I've also changed the battery. I have a friend who works with smartphones, and he gave me a lot of old batteries that are still working. This is a Samsung battery that I've connected to this USB charger and protection module. The Arduino, the rest of the modules and the display are working perfectly with voltages above 3.5 volts, so we can use this battery directly. The voltage from the battery is connected to this emergency switch and that will turn on and off the entire system. Finally, instead of the nRF24 radio module, I've used this other radio transmitter, because this one is easier to use. And to increase its power, we need to use it at more than 5 volts. So for that I have this boost converter module that will increase the voltage only for the radio transmitter up to 10 volts. This radio transmitter will send an OK when everything is ready and we push this button here. The receiver will detect that OK and do something. For example, turn on a PC, an LED, a relay or whatever you want. On the bottom board I have some holes for the speaker, so the sound will get out of the box. And that's it. I can now close the case. For that I use some of these insertion threads, and I place one of each corner hole. So then using some M3 screws I can close the case and this project is done. Just remember to upload the codes to the Arduinos. Now if the battery gets low, we can use this USB charger on the side and charge it. Okay, so let's give it another test. For this example what I want is to turn on that LED there on the receiver when the puzzle is complete. So let's see. So first thing is to power it on using the emergency switch.
Master key required.
As you can see we start with the drive LED red and a message on the screen. Now let's insert the master USB drive key.
Master key confirmed. Initialization code required.
As you can see we have a confirmation on the screen and the LEDs are now green. We now have to insert the 4-digit code. First I insert a wrong code to see what happens.
Wrong code inserted. Please try again.
As you can see it doesn't work, so let's try again with a good code.
Inserted code OK. You can now continue.
And there you go, we can now continue. That means we have to activate the key and those 3 toggle switches. 2 are going upwards and 1 downwards. Then I rotate the key and the fingerprint sensor will turn on.
Please scan your fingerprint.
As you can see we have another message on the display and the sensor is now blinking red. I first put a finger that is not on the memory and as you can see nothing happens. But now I place the good finger that is saved onto the memory and now we have access.
Correct fingerprint detected. Welcome master. You can press the on button now.
Finally, if I push this button here, a radio message will be sent to the receiver.
System initialized. Welcome back.
And there you go. Now each time I push this button I can change the state of this LED, which could be any other thing such as a relay, a motor, turning on a PC and so on. Okay, so for this test I have my puzzle here and now the receiver is connected to my PC. So let's just start it on.
Master key required.
I insert the master key.
Master key confirmed. Initialization code required.
I add the code.
Inserted code OK. You can now continue.
This is the button downwards, upwards, upwards, and flip the key.
Please scan your fingerprint.
Scan my fingerprint.
Correct fingerprint detected. Welcome, Master. You can press the on button now.
And now when I press this button, I will start my PC with a radio connection.
System initialized. Welcome back.
And there you go, that's how I can control my PC with this button now. And now if I press this button, I will turn it off. And there you go. So guys, use this idea and create your own escape room puzzle, adapt it to any other story. The players would have to find a drive key and the real key, then also find the 4-digit code and have the correct fingerprint. Instead of the fingerprint sensor, you could add a whole sensor inside and then place a small magnet inside of a mannequin finger and use that to simulate a fingerprint that the user could take from a mannequin inside of your escape room. So guys, that's how I've made this escape room puzzle box. You can use this idea and create your own. The important part is to be creative and know how to use each part. Instead of the key, for example, you could have a wire connection, maybe a fuse, or maybe some magnets and a whole sensor for the fingerprint. Maybe add a different code and some other mechanism. I will create more escape room puzzles in future videos of this series. If you like this video and learned something new, give me a like and also consider subscribing. Thanks again and see you later, guys. What's up, my friends? So this is the end of this video and I hope that you like it, and the most important part, as always, is that you have learned something new. And as you know, part of the support for this channel comes from Patreon, so I would really like to thank you to all that you are supporting me on Patreon. And if you are not supporting me on Patreon, you have all the links below, and the best that you could do is to just like this video, comment, or maybe share this video with your friends in order to beat this YouTube algorithm. So thank you very much once again, and I see you in the next video.